Module 13 and 14, the last two modules that we're going to cover this semester, talk about multivariable functions. So really what we're going to be doing over the remaining portion of the course is revisiting topics from derivatives and integrals and looking at how we apply those to functions with multiple variables or multiple independent variables. So before we get into the calculus, we want to spend this first section just talking a little bit about what multivariable functions are, why we need them, and how we perform some basic operations with them. So first we want to talk about this idea of multiple independent variables. So a function is essentially just a model for some real-world phenomenon. So when we deal with all these functions, particularly with the application problems we've encountered, every function is modeling the behavior of money, our investments, production, something like that. So we've already looked at what we could call simple models for cost, revenue, and profit. So for instance, one of these simple models would be about a manufacturing company producing standard types of surfboards. If the fixed costs to produce those surfboards are $500 per week, and there's a variable cost of $70 per board produced, then we could construct a weekly cost function for this company as $500, which would be that fixed cost, plus $70 times X for each individual board produced. So those are the types of problems we've considered so far. But now what we want to do is consider a problem that's very similar, but with a little bit more complexity. So consider the same company. In this case, they decide to add a high-performance competition board. The fixed cost to produce these competition boards is $200, and the variable costs are $100. So now what we can do is set up a combined cost equation for the production of both of these types of boards. So we could call this C of X comma Y. So we have one variable that's going to relate to the number of standard boards produced and one variable Y that's going to relate to the number of high performance competition boards that are produced. So our new equation will be the original equation that we started off with. So 500 plus 70x. And now what we're going to add to that is the $200 fixed cost for this new type of board plus that variable cost. And then just simplifying terms here, we get a cost equation of 700 plus 70x plus 100y. So now we have a function that has two independent variables, x and y, and this is getting us a step closer to what we could consider to be a real-world model, because most companies typically produce multiple items, or our costs, profits, revenue usually depend on more than just a single variable. So now we have functions of two independent variables where x and y are both independent variables in that function, and the dependent variable is some third variable z, which in this case is equal to our cost function evaluated at two particular values for x and y. So typically x has been our independent variable, y is the dependent. Now x and y become independent variables, and we have this third variable that we introduce, z. So instead of ordered pairs, x, y, which have typically been the solutions to some function, we'll now consider ordered triples. X, Y, Z. So for a solution, any value for our cost equation, we're going to plug in a value for X and Y and get a resulting value for Z. So our solutions will be ordered triples, X, Y, Z. Or similarly, we could represent that as X, comma, Y, comma, f of x, y. So either some function notation or just z by itself.